All right, class. So part 5 is a mixture of all the exponent rules that we have. Before we take a look at a couple of examples from there, what I wanted to do is just to review the exponent rules themselves. So I wrote them down here. This particular rule set right there tells you all the exponent rules that you have. So we started off with the very basic one, which was a raised to the 0. Remember that essentially becomes 1. Any base raised to the first power will be that base itself. And then we get into the product family. The product family being that if you have the same base, you keep the base and you add the exponent. Remember, this is the main one that you want to concentrate on. You have the two other cousins that we just went over with. And then you have your quotient rule. This is the second major rule that we want to remember. We want to remember them because those are the ones that we're going to use more often in our next couple of sections. Then you have the cousin to the quotient rule, which is similar to what you have for the product rule. And finally, you have the negative exponent rule. We kind of introduced it in the middle of the section, but the negative exponent rule is kind of separate from those two. So if you ever have a negative exponent, make sure that you rewrite it. So you have 1 over that base itself raised to the positive exponent. Alright, so that is a short summary of all the exponent rules that you're going to have. In section 4.2, we're going to take a look at more at the negative exponent rule. We're going to concentrate more on that. But for right now, we're going to go ahead and take a look at some of the examples that you have in part 5. Once again, part 5 is a mixture of all the examples that you have here. So we're going to go ahead and take a look at 5a. So once again, we're still in section 4.1. We're still dealing with the exponent rules here. So this is part 5. All right, so letter A there, we have 8m raised to the third raised to the fourth over 8m raised to the second, all of that encapsulated. So once again, we're going to have to think about this one. So we're going to have to take a look at those exponent rules that we talked about right there. Well, you pretty much know that these two do not apply yet. Same thing with this. So we take a look at rule number 4. Well, this one is going to apply. We're going to go ahead and distribute the exponent. So first, let's take a look at the top. 8m raised to the third raised to the fourth. Once again, 8 is the same thing as having a 1 right there as the exponent. So 1 times 4 is 4, so it'll be 8 raised to the fourth. And for the exponent here, we're going to go ahead and borrow a tip from this one. We're going to go ahead and multiply the exponents. So this will be m raised to the 12. We multiply 3 times 4. Now, normally we would have to simplify this numeric base, but since we have another 8 at the bottom, we're going to leave that until a little bit later on. Same thing here. We're going to distribute the 2 to both the 8 and the m. So it's to the first power and the same thing for the m. So we're going to go ahead and distribute the exponent. So this will be 8 raised to the second. And then 2 times 1 will be m raised to the second. Once again, we do not want to simplify this. We're going to take advantage now of your quotient rule, which states that if the bases are the same, you just simply subtract what? The exponent. So same thing here. We're going to keep the 8. We're going to subtract the exponents, 4 minus 2. Once again, 4 minus 2, that will give you 2. And we're going to do the same thing with the m. So we're going to keep the m, and 12 minus 2 will give you m raised to the 10th. So now we're going to go ahead and simplify this. 8 raised to the 2nd. 8 times 8 is 64. And we're going to keep the m to the 10th. And that will be your answer. All right, let's try one more. Let's take a look at letter D. Once again, keeping handy these exponent rules. We're going to need them quite a bit. So letter D here. And let me go ahead and write it first. You have negative 3a squared b to the 3rd raised to the 2nd a. All right, so we're going to go ahead and calculate, first distribute the exponent to each of these bases before we deal with this one right here. So first, we're going to have negative 3 raised to the 3rd. Make sure, to the 2nd, excuse me, make sure it's encapsulated with the parentheses. The same thing with the a to the 2nd. A to the 2nd times raised to the 2nd will be a raised to the 4th. And the same thing with the b. B raised to the 3rd raised to the 2nd. 3 times 2 is b to the 6th. All right. So all of this, we got to simplify. Once again, we keep this in parentheses. So first, we're going to simplify this. Remember, the negative 3 is encapsulated, so it's negative 3 times negative 3, which is positive 9. So it's 9a to the 4th, b to the 6th, parentheses, a, and b to the 3rd. If it throws you off because it doesn't have a number there, we could go ahead and put a 1 there. So we just multiply the numeric bases. 9 times 1 is 9. And then we're going to take a look at the product rule. Remember, if you have like bases and you're multiplying them, you add the exponent. So you have a to the 4th years. This is a to the 1st. So this will be a to the 5th. And the same thing with the b. B to the 6th times B to the 3rd, B to the 9th. There's nothing else left to do on this one, so that's as far as we're going to take it right there. All right, so this concludes section 4.1. Once again, keep track of what you're doing and make sure that you email me or call me via my phone. All of you know my phone that's on the syllabus, and I send it in Blackboard. Make sure you check your announcements on Blackboard and also go into the content folder. The content folder has the weekly folders for each of the following weeks. And we'll be discussing that a little bit later on. Take care, and next section that I'm going to do is section 4.2.